Hello everyone, welcome to my new programming club. Today we will be solving another daily Leetcode challenge. And before proceeding with the challenge, I would like to inform you that there was some irregularity in uploading the content on the channel because I was busy with my mid-semester examination. From today onwards, the content will be regular. I was not able to upload since past 2 days. And also for the weekly contest, I will try to solve it tomorrow and try to upload the solutions. And so without further delay, let's try to solve this problem. So what the problem statement says is, you are given an array of integer nums sorted in non-decreasing order. Find the starting and the ending indices of ending position, or say ending indices of a given target value. So let's say your target is 8. So the first leftmost position on which 8 occurs is 3, and the rightmost position on which 8 occurs is 4. So it's mentioned that your algorithm should be running in of log n time runtime complexity. So let's have a look at the constraints. The length of the nums array will be of order 10 raised to power 5, and the elements will be ranging from minus 10 raised to power 9 to 10 raised to power 9, and it's mentioned that nums is sorted in non decreasing order, which is increasing order, and the target will also be ranging from minus 10 raised to power 9 to 10 raised to power 9. So how we will be solving this problem? If the constraint that we have to solve it in O of log n time was not mentioned, then we could have just applied a linear search. But since it's mentioned that your algorithm should be running off log n time, where n here is the length of the nums array. Okay. So to achieve this particular time complexity, for linear search, it would have been a linear time complexity, which will be order of n. And for this particular time complexity to be achieved, we will be using binary search. Basically, the runtime complexity will be O of log n, and binary search will be little tweaked to adjust these solutions. Okay. So with few tweaks, we will be able to solve this particular problem with the help of binary search. Two binary search will be done. One to find the starting position of target occurrence, in array, and this will be first binary search, and second binary search will be to find the end position of target occurrence in array. And it's mentioned that if the target is not occurring in the array, then you should return -1 comma -1. Okay, so let's try to implement. This is the vector that we will be returning. Okay, and this vector will be of size 2, and two functions will initialize the values in these vectors, or change the values of this vector. Initially all the values will be 0 in this vector. So for the first one, we should return the starting point of the given value. So for the starting point, we will make a function and let's call it lower bound. Lower bound denotes the starting position, or let's call it find start position. And we will pass nums vector and target to it. And similarly, result of first index or the ending position will be find end pos, and nums and target will be passed. Okay, at last you will return your result. Now let's declare these two functions and implement them. It will be an integer value will be returned for the index. So private int find start position vector nums and your target value. The implementation is pretty much similar to a standard binary search. We will be searching our answer or our say starting position along the indices, and indices will be ranging from 0 to nums size -1. Okay, and your answer will initially be storing -1 to indicate that the value cannot be found, and then we will apply standard binary search. Those of you who are not familiar with binary search, I will be providing a link of an article describing what binary search is. Okay, and now let's jump back to the implementation. Then a mid position will be found uh, with the help of this left and right values of indices. To prevent the integer overflow, we are using this method. This is nothing but left plus right whole divided by 2 if you expand it. Okay, or you say simplify it. If let's say your target value is equal to nums of mid position, then in this case you will move towards the left hand side since you are required to find the starting point. Move towards left hand side to find start position. Okay, so we will be moving towards left and our answer will be current value of mid position and left. Since our search space will be decreased, so our right pointer will be mid position -1. Okay, and if this is not the case and your target is greater than, let's say, your nums of mid position, okay, then what you will do is your answer will be mid position. Answer will not be, this will not be your answer. You will be finding that number. So since your target is greater than the current number, then you will move towards the left, right, and you will search in the what say, since it's greater, you will search for the right hand side. Okay, move towards right hand side. So your search spell will be move towards the right hand side part. So your left will be mid position +1. basically what you are doing is you are placing left here initially and then right here, and then you are finding a mid position. Okay, then whether this mid position is equal to target or say greater than target or less than target, depending upon these cases, you will reduce your search space. Reduce your search space accordingly. Okay, this is the logic. And if that's not the case and your target is, let's say, lesser than your nums of mid position, then you will move towards left. Okay, and your right will be mid position -1. So at last you will return your answer, and pretty much similar implementation for be the ending position, just with a little difference that what will be the difference? The difference will be that when we find the number equal to the target, instead of moving towards left, we will move towards right. This will be the difference. We will be moving towards right, and your left will be position +1. Okay, and let's try to submit for the sample test cases. I think it's complete now. Functions we have implemented: find start position. Basically we have implemented these two functions, find start position and find end position. These are two binary searches. As we find the number in the start position function, we will be moving towards the left hand side to find the beginning of the occurrence of this particular target. And as we find the occurrence of target in nums array for end position function, we will be moving towards the right hand side. Okay, and then let's try to submit it once for the sample test cases. Let's see if it's running fine or not. It's getting some error, so nums will be there instead of num. Let's try to submit again or compile the code for sample test cases. As you can see, it's getting accepted. So let's try to submit it. Let's see whether it's getting accepted or not. So as you can see, it's getting accepted. So the overall time complexity will be order of n, log n. Okay, this will be the just a second. This will be the overall time complexity, and space complexity wise it will be order of 1 only, since we are not using any extra space. So if you are still having any doubts, please feel free to ask them in the comment section. I will be more than happy to answer them. So thank you for watching. Thanks.